Engineers have to make things and put things together when they are working, quite often actually. And so that means sometimes you're going to have to work with nuts and bolts. So let's describe a situation where we have to work with some nut here. So we'll draw some hexagon to represent a nut that we have to turn. And then around it, let's draw some wrench. And so we wrap this wrench around it, and give it some length here. Draw the edges and just make it look nice and neat, right? There we go. So we got some wrench, and just in case you can't, tell what I've drawn from my beautiful picture, let's go ahead and label. How dare you not be able to see what this is? But let's label these two, and let's say this nut is 1 inch, or it has a radius, I should say, of 1 inch. So from the center here, it is a radius of 1 inch. And let's say that the wrench has a length of 6 inches. And so we'll just extend this out just a little bit here. And to the end, that is 6 inches. And let's say that the torque required to turn this nut would be 10 foot-pounds of torque. Well, then my question would be, what would be the force required to turn this wrench here? So what would this force of my wrench have to be to get that torque? And for that matter, what if we didn't have a wrench? What would our force be if we didn't have a wrench? So what would this force just on the nut be if I was just turning this with my fingers? So let's go ahead and figure out both. Let's start by solving what would be the force of our wrench. So let's say this math is the math with the wrench. So we know that torque is 10 foot-pounds, and we know that our formula for torque is our force multiplied by our radius. And the question is, what is our force on our wrench? And we know our radius, our distance to our center point from the applied effort of our force here, this force W, is 6 inches from the center, which would be our radius, and we can rewrite that 6 inches as half a foot, so we could just write this at 0.5 feet, because 6 inches is half of 12. And so this becomes very simple. We could say, well, torque, again, equals 10 foot-pounds, and we know that is equal to our force multiplied by our radius, and we don't know the force applied to our wrench, that's the point of this, but we can multiply that by our radius, which we just said was 0.5 feet. And so to solve for our force, all we have to do is just divide by 0.5 feet on both sides. And it's just a simple algebra equation. So we get 0.5 feet. And then we know, okay, on the left, feet will cancel out. And then 0.5 and feet will cancel out completely on the right. And so we're left with pounds on the right. And so all we have to do now is figure out what's 10 divided by 0.5. And to figure that out, we'll just pull out our handy-dandy calculator. We'll say, what is 10 divided by 0.5? And we get 20. And so what does that mean? So what we would say is our force applied to our wrench would have to be 20 pounds to create 10 foot-pounds of torque in order to turn this nut. And so that's the force that we would need to apply to the wrench to create that torque. But what if we were just applying that force with our fingers to the nut? So what if we were doing this without the wrench? How much force would we have to apply to this nut with just our bare hands to create the required torque to turn this nut? So the torque is still our force times our radius, but this time we're going to work with a different radius. And so the question is, well, what is the force applied to the nut? We don't know, so we'll just say force N equals question mark. And our radius is 1 inch, but just like before, inches is the wrong unit for foot-pounds, so we need to convert that to feet. And there's 12 inches in a foot, so 1 inch would just be 1/12 of a foot. And so that's our radius. And the required torque hasn't changed. We can still say that that is 10 foot-pounds. 10 foot-pounds of torque to turn this system. And we could set that equal to our new force, which is our force applied to the nut, multiplied by our new radius, which is 1/12 of a foot. So 1/12 feet. And what will we get? We would do the exact same thing. We would just divide by 1/12 feet on both sides. And you might know, well, if we're dividing by a fraction, we can just multiply by the inverse. But if you don't know that, if you don't know how to do that in your head, these cancel out over here and feet cancel out over here. We can always just pull out our handy dandy calculator. It's the same thing. This time it'll be 10 divided by, and I'm going to put this as a fraction, so I'll hit my numerator over denominator button, divided by 1 over 12. And we get 120. And if you don't have this kind of calculator, what you could have done instead was just say 10 divided by and put in parentheses 1 over 12. You have to make sure that you specify that this is a fraction you're divided by, or you might get a weird answer. But we get 120. So what does that mean? Well, that means the force we would have to apply to the nut with our bare hands, with just our fingers, because it's such a small thing, you'd have to use your fingers, right? You couldn't get a good grip with your entire hand, would have to be 120 pounds. And so I would argue that you get a really big advantage using this wrench. You would have to use a lot less force to turn this nut if you use this wrench. It would give you the same torque in the end, which is measured in foot-pounds, but it would require significantly less force, which would be, again, just a huge advantage. But more on that in future videos.